What's up, everyone? I had around 20 minutes before a call, so I wanted to quickly do a LeetCode. Today's problem is subsets, and it falls under Google's category of problems that they ask. And an array of unique elements return all the possible subsets or the power set. For those who don't know, power sets, they're basically 2 to the n power sets for any given set of numbers, including the empty set and the entire set. The solution must not contain duplicate subsets. Return the solution in any order. So the way we approach a problem like this is, for any given element, we take a path where we include that element and one where we do not. First, we're covering the 1. We take a path where we don't include the 1, and we're taking a path where we include the 1, right? And we go to 2. The path where we don't include any of these is the initial one. Path where we include the first one, not the next 2, is this one, and so on and so forth. And in that way, we're considering all possibilities. And so logically, if we wanted to cover cutting this out, rename this to subset. First, if I is greater than or equal to len of subset, len of nums dot append subset dot copy. And outside we say if subset dot append nums of I, then we call backtrack on I plus 1. Also do a subset dot pop, call it backtrack on plus 1. Effectively, these are the 2 routes we can take. At the end, we're just going to go ahead and call backtrack initially on 0, which would signify the first element of the array. Return res, which is our resulting array. And here, return, break out of this loop. We're appending a copy because we want to append. If we just append subset, then it's going to reference different things at different points in time, and we don't want everything to be modified to the same thing. So if I remove the copy, you're going to notice that, see, it all references the last value that it holds. So we got to include the copy in there, but hopefully that was a straightforward explanation as to how backtracking works. In a sense, in any given iteration, we are considering a possibility and then iterating on that until we get to the length of the entire array. We're going to append that on. So the reason backtrack happens is this is our core logic, just the last thing we're writing. Our core logic of appending and then iterating and then removing and then iterating is happening at the very end. And we're checking at every iteration whether we've hit that threshold to break out of that loop or function call. Hopefully this was insightful. See you later.